Our first type of special right triangle is a 45, 45, 90 triangle. 45, 45, 90 triangles are named exactly how they're supposed to be. They're named for their angles. So notice we have a 45 degree, another 45 degree, and a right angle, also known as a 90-degree angle, in each one of these triangles. So the ratios of the sides are always the same for every 45, 45, 90 right triangle. So what does that mean? So remember with isosceles triangles, 45, 45, 90 triangles are isosceles, which you may remember means that it has two equal angles, the base angles, and two equal sides. The two equal sides are these two right here, the ones across from each 45-degree angle. And those are the legs, remember. Remember, the legs of a right triangle, they form the legs of the triangle are the ones that touch the right angles. So if we think of the legs as always the same for 45, 45, 90 triangles, you can think of the legs as S. S for side. So I'm going to label both of the legs as S. S and S. S and S. The hypotenuse for every single 45, 45, 90 triangle is S times the square root of 2. S radical 2, you can think of it as. So those are not 5s, those are S's. So S, S, and S square root 2. So we use the information given to us in a 45, 45, 90 triangle to solve for the other sides. And this is without using the Pythagorean theorem. So the key is labeling your sides. So notice, if this angle right here is 45 degrees, we're looking at example 1. If that angle right there is 45 degrees, which one also has to be 45 degrees? This one right here, right? And you know that because 45 plus 90 subtracted from 180 is also 45. But you also know that every 90-degree angle, or every right triangle with one 45-degree angle also has to have a second one. So based on the fact that we have those two 45-degree angles, we now are going to name our sides. So remember, the two sides that are across from each 45-degree angle, we label as S. S and S. So this X side, that's S, and the 8 side, that's S. Remember, those two S's are both congruent. So if we know that this one is 8, so if we know that this one is 8, we know that this one also has to be 8. So X has to be equal to 8. So we can just say S equals 8. Okay. Well, we know that Y, so S is equal to 8, and therefore X is 8, because S and X are the same thing. So then we have Y. Well, Y corresponds with this one up here, S root 2. Circle it in yellow. S root 2. That's what Y represents. So if we have that Y is the same thing as S root 2, and we know that S equals 8, it would be fair to say that Y is 8 times the square root of 2? Yes, that is what Y is. 8 times the square root of 2. So, that's the basic gist of solving these kinds of problems. I'm going to show you a couple more as well. So, number 2. We're looking at number 2. We've got a 45, another 45-degree angle right there. And then remember, our two sides are S, and then S root 2. Well, we think, okay, which of these sides do we have information about? Do we have X, Y, and O? 25. So we know that 25 is equal to S. Well, if we know that 25 is S, and S is also here, then what do we know Y is? Well, Y has to be 25. And X, we know that X is the same thing as S root 2. Well, do we know what S is? Yes, 25 is S. So X has to be 25 times the square root of 2. So 25 square root 2. So again, notice what we're doing. We're using the information seen in the problem and setting that number equal to S, or equal to Y, or equal to X. Whichever side of the triangle we have information about. This one we had 25. This one was Y, that wasn't enough. This one was X, that wasn't enough. So we had to continue to solve until we found X and Y. So let's do another one of these. Number 3 is a little trickier. It actually takes some algebra to solve. So remember, there's our 45-degree angle. So we have another one over here, 45. So let's label our S's. Remember, the S's are the two legs. So S is the same thing as X, and S is Y. And this 19 corresponds with the hypotenuse. That's S radical 2. S radical 2. You may find what we did with radicals convenient. What we do with radicals either on Wednesday or Thursday, depending on what period you're in. So S radical 2. So notice, we do not have information about X. We do not have about Y. But we do have it about this hypotenuse here. So we know, so we set that S root 2 equal to 19. So we say S root 2 is equal to 19. And our goal is to solve for S. So what is S going to be? Well, how do we solve for S when it's S times root 2? Well, to solve for S, we would divide by root 2. So we divide by root 2. So we get S equals 19 over root 2. Well, if you're having deja vu here, you should be. We discussed this concept in class Wednesday and Thursday. What's wrong with this answer for S? S cannot, remember, you cannot leave a radical in the denominator. So in order to rationalize the denominator, essentially get rid of the radical, we multiply by that radical on top and bottom. So since this radical is square root of 2, we're going to multiply by the square root of 2 over the square root of 2. This turns our denominator, root 2 times root 2 equals root 4. And our numerator turns to 19 root 2. And remember, root 4 can also be written as 2. So we have 19 root 2 over 2. And that is what S is. And remember, S is equal to X, and S is equal to Y. So since S is 19 root 2 over 2, and S is X and S is Y, then X and Y are both 19 root 2 over 2. 19 root 2 over 2. So that is how we find X and Y. So that is how you use 45, 45, 90 triangles to solve, or use special right triangles to solve for the unknown sides of a special right triangle. Okay, so let's get into 30, 60, 90. It's the same idea, but there's just, rather than two sides being the same, none of the sides are the same. But the shortest side is still S. Just like it was with 45, 45, 90, notice both of the legs are the shortest sides of this right triangle. They're just both the same. So they're both S. So in this one, the shorter leg is S. The shorter leg, you can eyeball it here, it's this shorter one, but it's also the angle across from the 30 degree. It's the side across from the 30-degree angle. So that one's S. That one's S. The longer leg, the leg across from the 60-degree angle, is S times the square root of 3. So S times the square root of 3. And then remember how the hypotenuse for the 45, 45, 90 was S radical 2? Well, it still involves a 2, just not a square root of 2. For a 30, 60, 90, it's just 2 times S, 2S. 2S. So we have S for the shorter leg, S root 3 for our longer leg, and 2S for our hypotenuse. Okay, so again, just like with 45, 45, 90, the key is labeling your sides. Notice the side across from the 60-degree angle, that is our S root 3. So S root 3 is equal to X. S root 3 is equal to X. y is equal to, that's the hypotenuse, y is equal to 2s. And 5 is equal to s. So if we already know what s is, it's fairly simple to solve for x and y. We just substitute in. Here's s root 3 is equal to x. So I can replace s with 5. So I say 5 times the square root of 3 is equal to x. Do I have what x is? Sure do. X is 5 root 3. All because we knew that this side was s, and that's labeled as 5. Okay, now I can do the same thing with this other one. Y is equal to 2s. And since s is 5, I can take my 5, plug it in for my s right there, and say y equals 2 times 5, which is y equals 10. Please don't get confused by the fact that 5 and s look very similar. All the s's here are written in orange. So orange s, orange s, orange s. And then the 5 is in a different color. 5 root 3 and then 2 times 5. That's not an s. Even though 5 and s look a lot alike. Okay, so try number 5. Try number 5. Pause your video and try number 5. All right, here's number 5. So again, we start by labeling our sides. Our sides are labeled as, well, the one across the 30-degree angle, that's our shortest one. Remember, the shortest leg is s, so we call this one s. So 14 is equal to s. Let's rewrite that so it's a little clearer. 14 is equal to s, okay? The other leg, y, that's s root 3. So y is s radical 3. And then our hypotenuse, that is 2s. So we have what s is. So just like with the first problem, this will be pretty easy. So since s is 14, I can rewrite y equals s root 3 as y equals 14 root 3. Just replacing my 14, substituting in that for s, since I know s is 14. So my y is 14 radical 3. Now I can do the same thing with x over here. Let's do it in purple. So I know 2s equals x, 2s equals x, and I know my 14 is my s, so I can replace that s with a 14. 2 times 14 is equal to x, so 28 is equal to x. You might be noticing how these are a little simpler when you are given what s is, rather than when you're given what 2s or s root 3 are. We're about to do one where we're not just given what the shortest side is. We have to use the algebra to solve for what s is. Okay, so again, we label our sides. The shortest leg, or the leg across from the 30-degree angle, that's s. So we label this as s. Longer leg, s root 3. So y is equal to s root 3. And then the hypotenuse, that is 2s. So in order to figure this out, we need to know which one do we have information about. Well, we have information about the hypotenuse, 32. So we know that 32 is equal to 2s. Well, to solve for s, we just use the algebra. So we divide by 2 on both sides. And we get 32 divided by 2, which is 16, is equal to s. So we have our s. Notice they didn't ask us for s. But it's going to be very easy. Once we find s, it's very easy to find x and y usually. Because notice, we have this other equation over here. Let's circle it in brown. S is equal to x. Well, since I know s is 16 now, I can just take 16, plug it in for that s, and say 16 is equal to x. And that gives me what x is. So x is 16. And then y? Well, y is simply s root 3. So I can take my 16, which I know s is, substitute that in for the s right there, and say y equals 16 root 3. So 16 root 3. So guys, the key with these, you are labeling your sides as s root 3, and 2s, based on which is the shorter leg, which is the long leg, which is the hypotenuse. And then based on which one we have information about, the shorter leg, the long leg, or the hypotenuse, you work from that to find what s is. You work from that to find what s is. Next, we're going to do one that involves the rationalizing the denominator. So let's find one that looks like that. So let's look at number 8. Number 8. So for number 8, so again, we always start by labeling our sides. Make sure you're referring to your note sheet. So remember, this is 60, so this one has to be 30. And the shortest leg is the one across from the 30-degree angle. So that's s. Remember, the shortest leg is always s. So y is equal to s. We have that first. Then next we have our longer leg. The longer leg we label as s root 3. So 20 is equal to s root 3. So we have that. And then lastly, we have the hypotenuse. We always label that as 2s. So 2s is equal to x. So which one of these three equations, 2s is equal to x, y equals s, or 20 equals s root 3, which one of those three can we use to solve for s? We use 20 equals s root 3. That's the only one with the only variable in it being s. So let's solve it. So recall from Thursday or Wednesday, how do we solve when we have 20 equals s root 3? Well, that's s times root 3, so we have to divide by root 3. So we divide by root 3 on both sides, and we get, I'm just going to flip it around, s equals 20 divided by root 3. Now, is that proper math etiquette to leave it like that? No, it is not. You must rationalize the denominator. Get rid of the radical in the denominator. So the way that we do that, we multiply by the denominator over itself. Square root of 3 over square root of 3. We're multiplying here. So it turns into 20 times the square root of 3 over 3. And notice, sometimes that 20 and that 3 will cancel out, or will simplify in some way. But this time it does not. So that's our s. That's our s. So that's s. Well, notice y equals s right here. So guess what y is going to be? It's going to be s. It's going to be 20 radical 3 over 3. Just like we were before, we're taking this s, substituting it into our two other equations. So for our other one, we've got 2 times s. So 2 times 20 root 3 over 3 is equal to x. And remember, 2 is the same thing as 2 over 1. So you're multiplying across the top, multiplying across the bottom. So it turns into 40, which is 20 times 2. 40 radical 3 over 3. 40 radical 3 over 3. And that is what x is. 40 times the square root of 3 over 3. And there we go. So there's our x and y. So notice, all we are doing, to recap, we are labeling our sides, then solving the appropriate equation for s based on which of the three equations we can solve. There's only one of the three that we'll be able to solve typically. All right, let's look at number 9 together. Number 9. So for number 9, we have another 30, 60, 90. 30, 60, 90. Because that's 30, that's 90. This has to be 60 because the three angles have to add up to 180. And again, we label our sides. The 30 is always across from the s side. So s is equal to x. The 60 is across from the s root 3 side. So 9 root 3 is equal to s root 3. We'll get to that in a second. And then the y, the hypotenuse, is always the 2s side. Always the 2s side. So which one do we have information about? The longer leg. So we work with this equation to solve for s. So remember, we have s root 3. We want to get s by itself, so we divide both sides by root 3. So notice, the root 3's cancel there, and they cancel there. So 9 is equal to s. So s is 9. And since s is equal to x, x has to be 9. So x is 9. And since y is 2s, that means y is 2 times 9, which is 18. And that is the key to solving these problems. On the next page, there are several mixed practice problems. I'm going to do just a couple of these, and then you are free to go ahead and start on your homework. So, find the value of each variable. We have our 45, 45, 90 here. And how do I know that? Because if you have one 90-degree angle and one 45-degree angle, the other angle has to be 45. So remember, we label our sides. Refer back to your notes. So our sides of a 45, 45, 90 are S for the two legs. So y and x are both equal to s. And the hypotenuse is equal to s times the square root of 2. S times the square root of 2. So notice I only have the information about the hypotenuse. That's what I'm going to use to solve for s. So I'm going to rewrite this out to the side. 28 is equal to s root 2. And then I simply solve for s. So we divide by square root of 2 on both sides. So I have s is equal to 28 over the square root of 2. And again, not proper math etiquette, so we have to rationalize. We multiply by the square root of 2 over the square root of 2. And we get 28 times the square root of 2 over the square root of 4, which is 2. 2. Now, 28 divided by 2, that is 14. Remember, we still have this radical 2 hanging on. So that is what s is equal to. And then from there, the problem gets pretty easy. We found s. S is equal to x, and s is equal to y. So both x and y have to be equivalent to 14 radical 2. And there we go. So that's an extra 45, 45, 90 problem. We'll do one more. Let's look at number 14. Number 14. Number 14. Label our sides. We've got S. So remember, 30, 60, 90. So 30 and 60 have to be the other two sides if one's 30. That's the other two angles. And we know S is always across from the 30-degree angle. So S is equal to X. S root 3 is the 60-degree angle, S root 3. And then 2S is the hypotenuse. So notice, which one do we have information about? Got information about this one right here. Our longer leg. So notice, if 15 root 3 is equal to S root 3, you might just know automatically based on the pattern that S is going to be 15. But algebraically, we would divide both by root 3. Our root 3's would cancel, so S is equal to 15. So S is 15. And notice, S is equal to X, so 15 is equal to X, so X is 15. And then notice Y is equal to 2S, so Y is 2 times 15, which is 30. So our Y is 30. And there are several other problems that we could also practice. I guess we can do one of these. Let's do 17 and then 20, and then we'll be done. So 17. So for 17, we have another 45, 45, 90. 45, 45, 90. And we label our sides. Remember the two legs are always S and S. So S is equal to X, and S is equal to Y. We don't have enough information to work from there. But we do know that the hypotenuse is always S times the square root of 2. So the root 10 is equal to S root 2. So that's what we're going to use to solve for S. So root 10 is equal to S root 2. So just like we've been doing, we're going to divide by root 2 on both sides. And I get S is equal to root 10 over root 2, which that simplifies to radical 5. So S is equal to the square root of 5. S is equal to the square root of 5. So since S is equal to both X and Y, we know X and Y are both the square root of 5. And there we have it. All right, so number 20. We got a two-part problem here. We've got a 45, 45, 90, it looks like. So 45, 45, 90, and a 30, 60, 90. So let's use the 45, 45, 90 first to solve for x. So we label our sides. So for this 45, 45, 90, here's my s. So 32 is equal to s. And this other side's also s. And then my x is the hypotenuse, that's s root 2. So since s is 32, I know this side's also 32. So I can go ahead and write that in purple. So this is 32 right here. That's 32, that whole side length right there. I'm just going to trace it in purple. So that whole side length is 32. And then x is s root 2, and I know s is 32. Since s is 32, I can take that, plug that in right there. You get x equals 32 root 2. So I know x is 32 root 2. Okay. Now, y and z are both in this 30, 60 triangle. So I'm going to redraw this just for clarity's sake. I'm just going to draw it right underneath here. Okay, so this is 32. This is y, and this is z. And here's my 60-degree angle. So those are my givens, essentially. Those are my givens. And remember, 32 wasn't originally given, but I solved this 45, 45, 90 triangle to find that. That was 32. So I know this is 30. So now I'm going to label my sides, just like I always do with my s's, my s root 3's, and my 2s. So the side across from 30, that's s. So z is equal to s. Z is equal to s. Y, that's my s root 3. And my 32 is my 2s side. So notice, which one do I have information about that helps me solve it? That one right there. 2s is equal to 32. So 2s is equal to 32. I can just divide by 2 to solve for s. And I get s is equal to 16. So s is equal to 16. So that means, since this is s right here, 16 is equal to z. And y is equal to 16 root 3. So 16 is z, and y is 16 radical 3. That concludes the 8.2 notes. Good luck on the homework assignment. Thanks for listening.